What if there exists a cosmic creature, capable of swallowing hundreds of billions of suns? One that keeps growing, without stopping, shaping the fate of entire galaxies over and over again. In today's video, we're diving into Phoenix A star, the largest black hole ever discovered by humankind. But this isn't just a scientific story. It's something more. It's a question, a reflection. What does something so immense tell us about our place in the universe? Hello and welcome. I'm John, coming to you from Infinite Universe NTH, where we don't just look up at the stars, we look inward through them. Before we face Phoenix a star, let's revisit a fundamental question. What exactly is a black hole? It's a region in space where gravity is so strong nothing, not even light, can escape. According to general relativity, a black hole can be fully described using just three values: mass, electric charge, and angular momentum. Based on their mass, black holes are usually grouped into three types. First, stellar black holes, just a few times the mass of our sun. Then, intermediate black holes, thousands or hundreds of thousands of solar masses. And finally, supermassive black holes, millions or billions of times heavier than our sun. But Phoenix A star is something else. Something far beyond supermassive. Today we call it an ultramassive black hole. Phoenix A star is located at the center of the Phoenix galaxy cluster. This cluster lies approximately 5.8 billion light-years away from Earth. It's an incredibly dense, high-energy region filled with thousands of galaxies. At its very core sits Phoenix A star, inside a massive, highly active galaxy. It emits powerful X-ray radiation, so intense it stood out immediately in deep space surveys. Phoenix A star is estimated to have a mass of about 100 billion times that of our sun. Let that number sink in. 100 billion suns, all collapsed into a single point. For comparison, the black hole at the center of our Milky Way, Sagittarius A star, weighs about 4 million solar masses. That makes Phoenix A over 25,000 times more massive. Its event horizon, the boundary beyond which nothing escapes, is enormous. So enormous, it could swallow our entire solar system many times over. And it's not just big, it's bright. The gas and dust spiraling into Phoenix A star form an accretion disk. This disk becomes superheated, and it emits intense radiation, especially in X-rays. That's how astronomers found it, from more than 5 billion light-years away. Phoenix A star is so powerful, it revealed itself through the light of destruction. Like all black holes, Phoenix A star didn't start massive. It grew. And it grew in two main ways. First, through accretion. That's the process where gas and dust spiral inward, drawn by the black hole's gravity. As this matter falls in, it heats up. It forms a spinning disk of plasma, and it releases energy in the form of radiation. That's how black holes grow, one particle at a time, slowly, relentlessly. But accretion isn't the only way. In galaxy clusters like Phoenix, galaxies collide. And when galaxies merge, so do their central black holes. These collisions create more massive black holes. And in an environment as crowded as the Phoenix cluster, that means a lot of merging. Phoenix, a star, may have grown through dozens or even hundreds of black hole mergers. Each one a cosmic handshake, and another step toward becoming a giant. Phoenix, a star, isn't just growing, it's shaping its environment. Around the black hole, astronomers have observed powerful jets, streams of particles blasting out at nearly the speed of light. These jets stretch across thousands of light years. They punch through surrounding gas, heating it, stirring it, changing it. That heat matters, because when gas gets too hot, it can't collapse to form new stars. Phoenix, a star, is not just eating. It's regulating star formation across its host galaxy. This process is called black hole feedback, and it plays a crucial role in how galaxies evolve. Without feedback, some galaxies might grow uncontrollably. But with a black hole like Phoenix, a star, growth is kept in check. So in a strange way, this destructive force becomes a kind of cosmic architect, shaping galaxies, balancing creation and destruction, one jet at a time. So what made Phoenix A this massive? How did it grow to become the largest black hole we've ever found? There are a few leading theories, and each one opens a door into the early universe. First, it may have started massive. Instead of forming from a small collapsed star, Phoenix, a star, might have formed from the direct collapse of a giant primordial gas cloud. One so large, it bypassed the typical black hole growth stages. Second, it may have merged repeatedly. In the Phoenix cluster, galaxies collide frequently. Each collision can bring two black holes together. Over billions of years, Phoenix A star could have grown through dozens or even hundreds of these events. The third idea is more speculative. Some scientists believe that Phoenix A star might interact more efficiently with dark matter. If true, it could have pulled in extra mass from an invisible reservoir, helping it grow faster than ordinary black holes. None of these theories are proven, but each one gives us a possible path, a window into how monsters like Phoenix A star may have formed, when the universe itself was still young. How do we know all this about Phoenix A star? The answer lies in observation, collaboration, and the best tools humanity has ever built. First, the Chandra X-ray Observatory. It detects high-energy X-rays emitted from hot gas near black holes. Chandra revealed the intense brightness around Phoenix, a star, and the cavities in space carved out by its jets. Then, there's the Hubble Space Telescope. It gave us stunning optical images of the Phoenix cluster, showing galaxies, stars, and cold filaments of gas, some of which are still forming new stars. Despite Phoenix A trying to stop them, the Very Large Array, or VLA, added another layer. It picked up radio waves from the jets blasting out of Phoenix A star, letting us trace how far those jets travel and what they're doing to the space around them. But observations alone aren't enough. Scientists use computer simulations to model what's happening. These simulations recreate the physics near black holes and help us test theories about how Phoenix A star formed and evolved. It's a multi-wavelength, multi-dimensional effort, across light, across time, across human ingenuity. So here's the big question. Is Phoenix A the largest black hole ever discovered? For years, that title belonged to TON 618, a distant quasar with an estimated mass of around 66 billion suns. But more recent studies have revised that number. Some now suggest it may be closer to 40 billion. Meanwhile, Phoenix A star continues to impress. Observations indicate it may be over 100 billion solar masses. That would make it the most massive black hole we've ever confirmed. Not just massive, but record-breaking. Of course, the universe is vast. There may be other monsters out there, hidden in the dark, waiting to be discovered. But for now, Phoenix, a star, stands at the top, the heavyweight champion of the known universe. So now we know what Phoenix A star is, how it formed, and why it matters on a cosmic scale. But what if we dared to imagine what would happen if we got just a little too close? Let's imagine for a moment that we sent a spacecraft toward Phoenix A star, not to study it from afar, but to approach it. What would we see? What would we feel? And more importantly, what would happen to us? As we get closer, gravity increases. Slowly at first, then rapidly. The stars behind us begin to distort. Space itself bends around the black hole. Time slows down. To someone watching from Earth, we appear frozen, hovering near the edge. But from our perspective, we keep falling. The point of no return, the event horizon, comes into view. Cross it, and escape becomes impossible. Closer still, the forces become extreme. Gravity at our feet is stronger than at our head. This creates what physicists call spaghettification, a gentle word for being stretched into atoms. We wouldn't see the singularity. It's hidden, timeless, beyond all physics we know. So what happens next? No one knows. Not even the best equations in science. The inside of a black hole remains, for now, unknowable. Which makes it the perfect place for both fear and wonder. Phoenix A doesn't just raise questions about black holes. It raises questions about the universe itself. How could something this massive exist so early in cosmic history? Remember, Phoenix A formed billions of years ago, in a time when galaxies were still assembling, stars were still young, and space was far more chaotic. Some scientists think that ultramassive black holes like Phoenix A are leftovers from the early universe, fossils of a time we don't fully understand. One idea is that they came from direct collapse black holes. These would have formed from huge gas clouds, without first becoming stars. If true, that means black holes didn't just come after galaxies. In some cases, they came first. Another clue may lie in the way galaxies evolved. Phoenix A might have been at the center of a proto-galaxy, one that grew up around it. In this view, the black hole shaped the galaxy, not the other way around. And that's a radical idea, because it flips the traditional model of cosmic evolution and puts black holes at the heart of it all. If Phoenix A really is a relic from that time, it could be one of the oldest living structures in the observable universe. Black holes are strange enough already, but some theories suggest they might be more than just cosmic dead ends. What if, just maybe, black holes are gateways, not to destruction, but to something else entirely? This idea isn't new. It's been proposed by physicists, mathematicians, and yes, science fiction writers. One concept is the wormhole, a shortcut through space-time, a tunnel that links two distant points in the universe. According to Einstein's equations, wormholes could exist, at least on paper, and some solutions suggest that black holes might connect to white holes, regions where matter is ejected instead of pulled in. No one has ever observed a white hole, and wormholes, if they exist, might be unstable or microscopic. Still, the mathematics behind them is compelling, and they raise an exciting possibility. Could Phoenix A be a door, a cosmic passage to somewhere or something else? Probably not. But the idea itself pushes science forward, because asking impossible questions is often how we find real answers. Black holes are terrifying, mysterious, and completely invisible. So why do we keep looking for them? Why send telescopes across space just to find something that doesn't emit light? The answer is simple and human. We're drawn to the unknown, always have been. We crossed oceans without knowing what lay beyond. We flew into the skies, we landed on the moon, and now we look into black holes because they're there and because they refuse to be easy. Every time we study a black hole, we get closer to understanding space, time, gravity, and ourselves. It's not just about curiosity, it's about meaning, about finding light, even in the darkest places. Phoenix A is not just a discovery, it's a reminder that our will to know is greater than our fear of not knowing. Black holes don't just teach us about the universe. In some ways, they teach us about ourselves. They are invisible, silent, and yet impossible to ignore. They bend light. They slow time. They break the rules we thought were unbreakable. And maybe that's why we're so fascinated. Because deep down, we understand what it's like to face things we can't explain. Black holes are mirrors. They reflect the limits of what we know and who we are. They remind us that certainty is an illusion, that the most powerful forces can be the least understood. But here's the beautiful part. We still choose to look, to question, to wonder, even when the answers are hidden. And let's be honest, who else but humans would build billion-dollar telescopes just to stare at a hole in space? We're either brilliantly curious or beautifully stubborn. But maybe that's exactly what makes us worthy of asking the biggest questions. And maybe that's what black holes truly give us. Not answers, but the permission to keep asking. In a universe this vast, Phoenix A might be nothing more than a punctuation mark, a pause in a sentence we haven't finished reading. But it tells us something important, something deeply human, that science is not just about data. It's about perspective, about who we are, and how we fit into something far greater. At Infinite Universe NTH, we don't just tell stories about stars and black holes. We tell stories about humans within the cosmos. If this journey sparked your curiosity, stay with us, subscribe, and let's keep exploring together. This is John, signing off from Infinite Universe NTH. See you in the next frontier.